Welcome to Life is But a Stream, the web show for tech leaders who need real-time insights. I'm Joseph Vanise, technical champion and data streaming evangelist at Confluent. My goal, helping leaders like you harness data streaming to drive incident analytics, enhance customer experiences, and lead innovation. Today, I'm talking to Abhishek Walia and Anna McDonald. Anna is the distinguished technical voice of the customer here at Confluent, and Abhishek is one of our great staff customer success technical architects. Our first 3 episodes of Life is But a Stream explore the fundamentals of data streaming. If you haven't checked episode 1 yet, we highly recommend you pause this episode and come back after you've listened. Trust me, you don't want to miss out. In this episode, we'll explore the basics of stream processing, everything you need to know, no matter your level of expertise. You'll hear us talk about different tools, strategies, and hear real-world examples of data streaming in action. But first, quick word from our sponsor.
Your data shouldn't be a problem to manage. It should be your superpower. The Confluent data streaming platform transforms organizations with trustworthy, real-time data that seamlessly spans your entire environment and powers innovation across every use case. Create smarter, deploy faster, and maximize efficiency with the true data streaming platform from the pioneers in data streaming.
Welcome back. Joining me now is Abhishek and Anna from Confluent. Abhishek is a staff customer success technical architect, and Anna is our distinguished technical voice of the customer. How are you both doing today?
Excellent. Go Bills. Let's do it.
How about you, Abhishek?
I'm doing fine as well. Thank you.
Fantastic. Well, I do this, this is our second episode, but I have this thing where I immediately kind of go away from the questions and just kind of speak my mind. So I'm going to do that. I just want to thank you both for how much time you spend with our customers and how much you nurture them and, really help them get through their challenges. So I was a TAM back at AWS, so I know exactly what you guys do for a living. And I really appreciate how much you kind of, make sure that our customers are in fact successful. So, I want to introduce you both to the audience. So starting with you, Anna, what does your role caliber at Confluent?
Yeah. So basically what you find is it's unfortunate. Well, it's kind of a rule of life. The more time you spend away from something, the less natural it is. And I don't want to say disconnected because I think it does a disservice to the people who try their best to stay connected. But if you don't live something every day, it's amazing. They call it a diminishing skill or a diminishing point of view. And so one of the things that we know in the field is we spend every day, all day with customers. It's what we do. We live it, we eat it, we breathe it. And so, it's impossible to not understand their point of view. So being, the technical voice of the customer and in our office, what we do is we bring that point of view everywhere into Confluent, whether it's engineering, whether it's product. We work with our customer advisory boards. We, advise on use cases. And it really just makes it so what we're doing is solving our customers' problems in the right way. And we're bringing value to customers every day to make sure that what we're doing is usable. It's awesome for them. And we're working together as a team. So that's kind of what we do.
You're ensuring that voice is heard at every level of the company.
Correct. And I think the technical part is important too, because it's not just, hey, they need to do this. It's, oh, well, they also need to do it with this networking type, or these are the configurations you have to have because their use case demands it. Things like how fresh is my data? How often does this happen? And you really have to have an understanding of the engineering side from, Kafka internally, all of our, platform, and also, customer engineering side. So it's kind of a unique role, and I kind of like it.
Yeah, it's a great role for you, Anna. Quick, can you clear something up for me?
Mm-hmm.
So you're a Buffalo Bills fan.
Huge. Bills Mafia.
Is the Buffalo Bill, is that like a really cute Buffalo named Bill? Or is it a guy named Bill who's really in the Buffaloes?
No, it's neither.
Okay.
Like Buffalo Bills, or you can call them Bisons. It's spelled with a Z. Look it up. I'm from Western New York. That's how we say it. Deal with it. So, that's what it is. It's a pack of us. That's why they say circle the wagons, right? No one circles the wagons like the Buffalo Bills, baby.
I love it. Thank you so much for that.
You're
So
very
Abhishek,
welcome.
you're a siesta, and some people might mistakenly think that your job involves a lot of naps, but I know that's not the truth. Tell the audience what you do here at Confluent.
Well, I hope that included a lot of naps. That would be just salary and naps. That would be awesome, right? Who wouldn't want it? But yeah, I am a customer success technical architect working with Confluent, I think more than 5.5 years now. The job basically at this point is working with the customers, like what Anna said, right? Mentioned that we make sure that the customers are successful. That's the biggest priority. And they are happy. And in that order, right? They have to be successful first. They'll automatically be happy next. That's basically your job, to make sure that they're successful and they're happy. And if they have any needs, they're looking for something, there's a requirement from their end, which might happen in the next 3 to 6 to 9 months. We are the ones who take that in and make sure that the product teams and the engineering teams hears about it and are able to create a roadmap according to that. If there is something missing, we should be able to deliver that in a succinct time frame for the customer. And that's what our job majorly is.
Anna, in your words, who are our customers and who aren't our customers?
So I think that's a good question. I wanted to go to the field from engineering because the world is my customer. There's nothing that I'm not interested in, really, when it comes to like real world use cases. I often say like my value to the world is like pretty low if the power gets cut. Like, if there's like a global darkness, what have I done? I don't make mattresses. You know what I mean? Like it's rough. And so the closest I can get with the skills the guy gave me is to help those people, the people that are making 3D objects, right? Like, kind of power the world. So I think, you run a risk when I look at customers, I look at industries. These industries have facets, they have characteristics. There are, of course, individual differences, but by and large, they move as one. Some of them are lagging, some of them are leading. And in that way, everyone is our customer because we have customers across every industry. And if we have a new customer that's in a single industry and we focus on them at the expense of, okay, but what does everybody do, right? Like, is that normal? That's always what to ask ourselves, right? Is to weigh that, the good of everybody, all these customers, against a single individual. Especially when it comes to what are we doing in Kafka and Apache Kafka, right? Or Kafka Streams or any of our open source, Flink. These libraries, like we really want to improve those for, the masses. And so I think if you consider the world your customer as a source of information, not necessarily like, are we doing a ton, like going above and beyond for people who, aren't paying for things like my heat and power, speaking of power, right? You're focusing on serving those people, obviously, first and foremost, but I think you need to also consider the world as a data point.
Yeah, I really like that response. We're making data streaming accessible to anybody, regardless of what you do. I think that's a very good take. So when were you both introduced to data streaming and event-driven architecture? And a bonus, have you or any of your past teams ever had the pleasure of running open source Kafka yourself? Let's start with you, Abhishek.
Yeah, I was introduced to data streaming, and it's a pretty interesting thing because when I was working on this, I never realized it was actually event streaming, event sourcing, those kind of architecture models. And when we started using it, it was like, yeah, this is awesome. Everything is available right out of the box, and you didn't have to contact different teams and different things. Again, anyways, this was about 7 years ago with my previous employer, and we started looking into ingesting big data streams into Kafka. And basically, we started with a smaller ESB, which was not able to handle the load. We knew this was eventually it fell over, and we kind of knew that we needed something like Kafka to manage all that ingest, the power that it gives you. I kind of touched Kafka a little bit before this, but Confluent was like, hey, yeah, you're dealing with Kafka. And the ancillary of things around that. Before that, I only used Kafka. But as soon as I joined Confluent, I was like, oh, this ecosystem is much bigger than just Kafka. It's not just Kafka.
Right.
So,
you start with event-driven architecture, then you get to data streaming. I guess, those are correlated. And then you start working yourself up to DSP. So,
exactly.
Anna, how about you? When were you first introduced to data streaming and event-driven architecture?
I mean, event-driven architecture has been around forever.
Sure.
So that was like a way back. And I'm old. I'm 46. Well, I'm proud of that, man. Like, that's awesome. I can't
Absolutely.
wait. I get excited every time I get a gray hair. So I'm old school, but I would say the fact, like, Kafka makes it possible to do eventing in an elegant way.
Yes.
In the real world. So you, in like a greenfield environment, if you're going to pay people to, sit around and like architect, and you have no brownfields, like you've never had a mainframe, you have tons of time, Like, yeah, great. That's not how people live. You've got like 75 order systems because your company bought, like it's a mess. And I was always just kind of like, I would sit there and I'd go, yeah, that's great, except like, well, here's reality. And when I met Kafka, and I would say that was around early 2017, maybe late 2016, early 2017, I was like, well, oh, wait, this has legs. Like, it was the first time I saw something that one could take the data volume, right? If you're going to pump like like we truncated tables every night and reinserted. Try doing that with CDC with, by the way, no keys. So I don't want to hear anyone complain. Like, we didn't have keys and we did it. It's like, I'm like, that old woman back in my day. But you could take sorts from like 8 different databases, pump them all together, right? And then skillfully create these events. So it didn't matter all of your baggage. You could do it slowly, you could do it when it made sense. And I think to me, that was really a game changer in believing and seeing a way that eventing could really benefit and be used in the real world.
I know what you're saying. I think most of our customers are brownfield, right? Like there's a lot of great startups and things like that, and they have the advantage of starting green. But even they have to kind of be concerned about future state, because if you're a really successful startup, you may someday acquire a company and suddenly you have all that brownfield baggage. So you really have to future-proof your data streaming scenario architectures to take into account, hey, I may have legacy systems I need to introduce to this someday, maybe not, but you certainly don't want to put yourself in a position that you can't do that, right?
Look, everybody started as greenfield.
Like that. That's true. It's true.
Hey, like I said, right, the ESP piece, we started with the standard ESP. It was not able to scale, and we realized that pretty quickly.
Right.
So, I mean, a lot of times people just don't realize that the scale they're going to get to, like you just mentioned, right, the startup world, they'll have a minuscule scale, and suddenly they realize that there is so much influx coming in that now the scale is much bigger. Those are the times when you realize, I should have probably thought of this a little better, or a while before.
Yeah, undoing those choices is non-trivial. I mean, almost at any scale, but certainly at some of the enterprise scale that we deal with here at Confluent with our customers. So now that we know you both better, Anna, I'd like for you to help break down the fundamentals of stream processing, building off of what we did in episode 1 with Tim, where we talked about data streaming. So Anna, can you explain for those listening and watching what stream processing is and how it differs from batch processing?
Yeah, the way I like to say it, and I just had a really great conversation with my best friend, Matthias J. Sachs, Dr. Matthias, as he's known today, about this. And one of the things in eventing, I think it's a concept that people find it super hard to get your head around if you're like an object-oriented person, is there's no pause. Like in data streaming, there's no pause. You can't ever be certain. And when you think about a batch job, and I'm old, like I legitimately have 2 pagers and 2 flip phones in like a basket because it's fun to keep them from being on call. Like batch jobs, like you're throwing that in cron. There's a huge pause. That's why you have time, And so I think to me, the big difference in mindset and how you architect and how you plan is the fact that there's no pause. There's no pause in stream processing. You're continually ingesting data. And so it's not like I do all this stuff, then I move to the next step, then I move to the next step, and that can be incredibly difficult to get your head around. And to me, my mind, there are still use cases which are very difficult to event stream or use stream processing on because of the complexity. And not to say that there isn't a future for those. I think, with some fiddling, there's some things on the horizon that could make that, much, much easier and more elegant. But that's the main difference to me. And I know that probably sounds very abstract, but if you're somebody who's ever gone from normal to eventing, at some point you probably would have gone, when does it stop? It doesn't stop. I need it to stop. So
I like that. That key is
you'll understand what I mean.
Yeah. Right. Just, can I get a pause? Like, can you get a second so I could do something? No,
correct.
That's the whole point. You have to build your system to handle that pauseless world, right? Just a deluge of events.
Correct.
That's the key to real time, to building things that are real time though. So for our viewers and our listeners who may be a bit more familiar with data streaming, but not stream processing, how does stream processing differ from processing through the consumer producer application using those standard data streaming APIs?
Yeah. I mean, I think the difference is I'm a consumer. all I'm doing is ingesting information, right? I'm just getting some information and doing something with it. If I'm a producer, all I'm doing is producing data. I'm giving data away. Here it is. Look at it. It's beautiful, right? If I'm doing, usually when we say stream processing, what we mean is I'm consuming data, I'm doing a transformation to it, and then I'm giving it back to the world. So it's a coupling, and that's usually the definition, that people say. It's really that mutability in the middle, right? Where I'm enhancing, I'm enriching, I might be subtracting, I might be cleansing something, removing PII. It's not always additive. But there is a transformation that occurs before I'm sharing that back out to the world.
Now, can you share a real world example of stream processing in action? I know you probably have a bunch.
I do. I have one favorite one. Maybe I use it too much, but it's still my favorite because it's like Darth Vader. The stream, like sleep apnea masks.
Yeah.
I think that's a great one because, it's gotten to the point now where people are not only, having this information collected that can go with your consent automatically to your doctor from a durable medical device, right? And we know that, people say sleep apnea, ha, 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 but it can cause heart problems. It really, really can. And so these types of, adjustments, these medical devices can really save people's lives. And understanding that information in real time, streaming that information, knowing what's going on is huge. It's huge for, a number of the pattern matching, all of these things. And that wouldn't have been possible before. Right. So I think that's a real world example. One of my other favorite ones is, I kid you not, and I can't say who, there is a Department of Transportation in a state that can detect if somebody drops a couch on like the expressway. Yeah, totally. So they have sensors built up and they can tell if there is like basically they can tell if there's a decrease in speed. Now, it could be for something else, like an accident, But my favorite example ever was they were like, well, we knew you did a good job when we detected that somebody threw like a huge love street, like leather love street in the middle of the expressway because everyone was like slowing down and going around it. I thought that was awesome.
Oh, I love that. Like I could imagine seeing a traffic warning saying heavy traffic ahead,
Yeah.
or couch in road,
Correct.
I see out of the box
Was
thinking
awesome.
here, if nothing else.
Yes, exactly.
And-
Yes. So I mean, it's everywhere that you could possibly imagine.
So I really like your first example. I actually do have sleep apnea. I use a CPAP machine. So for any of our viewers and listeners, our devices, at least from this particular manufacturer, they can phone home. I think they have like 2G, 3G access, and they send data, opt-in data to our doctors, to make sure, are you wearing it? Is it effective? Are you still having events in the middle of the night? And then your doctor can remotely make changes to that. So it's really a fantastic example. So I appreciate that one, Anna. Can you explain how real-time stream processing helps organizations out compared to traditional processing methods?
Yeah, absolutely. So traditionally, and I'm going to use her real name, there's a lady named Ethel who like gets into work every morning and she's like, what went wrong? Like, who do I need to call today? Now you get an alert on your phone instead of talking to the lovely Ethel. I mean, that's the difference is, for example, like something simple like banking, like setting an alert if a payment or withdrawal goes through over a certain threshold, then getting that alert in real time. You used to have checkbooks, man. You'd have to go to a bank teller or an ATM, to try to figure this stuff out. I am an introvert, so talking to people is always exhausting. You're welcome. I'm on this. But it also allows you to have like flexibility in your life. Like I remember when ATMs, and I use that example a lot, like ATMs first came out, you don't even have to go to your bank branch anymore, right? Like what if it's far away? It's the same, if you're busy or you want to do like, you got kids, you got something, you can check these things. You're not going to get have fraud that goes on for a month because, I couldn't make it to the bank today to check my balance or it's about bringing value to your life where you are and where you're living. I will say that I think that it also should, and this is something I recommend to everyone, it's a new year, new you. It should give you more time to also unplug. So there's a tendency of people to say, I can do everything everywhere. I'm going to keep doing everything everywhere without taking a break. Like for me personally, I like to go antique shopping into like Goodwill and I like to find weird stuff and look up the history of it. It's nice. It's relaxing. So make sure you're like using those gains to bring some like zen into your life. It's very important. It's
That's
my
really
advice.
good. I never thought of that. Stream processing as like making our life's tasks more efficient, right? So we get time back so we can do the more fun things. Like,
Yeah, do something good with it though. Don't do
yeah,
more till you know, unplug.
right. You're like, this is efficient. Let me take some time back for myself. I like that.
Yes.
That's a very good mantra. So Anna, what is the, again, this is, this show is for someone who may have no experience. So this may seem like a very lay question, but I still want to ask it anyway for anyone who's here exploring all of this for the first time. What is the role of event-driven architecture in stream processing?
Yeah, I don't think it is though. Like that's a
Okay,
good. It's not.
interesting.
It's not an easy question to answer always.
Right.
We get asked that. Abhishek knows this. So, yeah, people, they mix the terms up, which is fine. Also, like, what are you, the grammar police? As long as people understand the concepts, you're good. But the difference between, and it's not even a difference. Like data streaming, it's just data that's streaming in, right? It's coming now. That data could be events, or it could be something else, right? It could just be
Sure.
observations. Eventing, the easiest way to tell if something's an event is it's something that happened. It's in past tense, simple
Mhm.
English. So when you look at a message, is it telling you that something happened in simple English? Or is it just a payload? Is it just an observation? Is it just that's the difference. And event-driven architecture is a way to, now that we can observe in real time the world, well, we got to be able to do something. How do you find a construct that lets you do something with all of this data? Now that I know what's happening, like it's kind of Big Brother, eh? But now that I can watch everyone sleep at night, I should probably do something about it. So that's where event-driven architecture comes in.
Would it be fair to say event is really data plus the timestamp?
No,
Okay.
it's really
Obs-
like, well, it's more like, for example, to use the sleep apnea thing, right?
Okay.
It's more like you could say, like, let's say that there's a range of good, right? We want to fluctuate. We want to make sure that this is, you could look at oxygen saturation. You could look at like a lot of things, right?
Sure.
Breaths per minute, like how long you've gone without breathing, right? I think that's one of the ones is like, the interval in which you
Correct.
do not take a breath, right? And they measure that by oxygen saturation, I think. Please feel free to correct me if I'm wrong. I'm probably wrong.
You're
So
onto it.
I'm,
Basically, there's this
yeah,
like measure
I'm not
called
a,
AHI. It's like how
yeah,
many
I'm not a
events you
doctor.
have. There's
All
some that
right.
are obstructive, some are central. Like
Yeah,
exactly.
see,
Like,
it's complex. I'm just making
not
it
an
simple.
apnea show though.
Correct, right? So the way that you detect that, right, is by sending these measurements.
Yes.
Now, an event that you would look at those measurements and you would go, oh, we are outside our bounds.
Yes.
I'm going to send an outside of bounds event. Data coming in, I'm able to do events. Now, that's not to say you can't throw events directly. You can. But that's an example of the difference. One is the data, the other are the events that you're grasping from those data. Now, not to say you couldn't do that on firmware, right? Not as
Right.
flexible. It's probably not as flexible. Now you can make changes, right? Probably more reliable. There's durable medical, right? Maybe that's some of the adjustments we make, but whoever's responsible, the event is based on what's happened and that sometimes comes from data streaming, if not an application directly. So that's the way that I look at it. Because what else would you do with all that data?
It's true.
You know what I mean? You need to do something with it.
Absolutely. Actionable data needs action. So tell us about Kafka Streams, Anna. Was K-Streams the original stream processing option for Kafka?
I mean, I think yes. I would go absolutely yes. It was absolutely done with the intent of here is a simple way to do event streaming, right? According to the Kafka protocol, inheriting all the goodness of Kafka, along with some of the things that in some use cases are not so good, right? Because you're bound by partition. And I think the goal of it was, EOS, for example, transactions. The first citizen of transactions was intended to be K-streams, right? That's how we get, exactly one semantics. And I think it's been hugely popular. I would say, the right way to ask it is what you said with Kafka. You can always use external frameworks like Apache Streams has been out there for a very long time as well. There were other frameworks, but I would say, Kafka is the direct relative. Kafka Streams is a direct relative to Kafka. Now, that being said, too, it's only in Java, right? And so, I don't think it wouldn't be fair for people to it's not an opinion that I have. Now, do I love Kafka Streams? Yes. Did we win an Oscar, which I believe is right back there for I believe it says best streaming library in the world. And no, I'm sure I didn't order that. Also, yes. But it's a streaming library. It's a jar file. That's all it is. You know what I mean? And it makes it so accessible. That's where my heart is. When people get started, it's an easy way to get that mindset shift. And then if you need other tools for other things, you can build on that. But I think it's amazing. And again, it's just a jar file.
Right. Easy way to get started and get used to building things without pauses. I like that.
And that is 100% true. That's usually where you figure, they're like, but wait. You're like, but there is no waiting.
No. So how do you think organizations will use stream processing in the future? Do you have any visionary use cases in mind that we can geek out about?
I mean, well, I think that there are probably some really wonderful advances if done correctly, and locally, that can help with medical care. And we've already seen that where we see, AI detecting cavities, for example. There are places where there is a very low per capita rate of dentists. And so, and teeth, I mean, your mouth is like the gateway to a healthy body. It's just true, people, brush and floss. But, there are places all over the world where medical care is in short supply or unreachable. And so anything you could do with remote diagnosis, right, I think would be awesome and huge. I think that would be wonderful.
So our next segment is called the Playbook, where in this case, Abhishek is going to dish out some winning strategies for getting old, tired, unmoving data in motion. So I'm very eager to have your insight here. So Abhishek, we're going to focus on you.
Yes,
How do
sir.
frameworks like ksqlDB and Apache Flink differ in their approach to stream processing versus, say, K-streams?
Ooh, that's a heavy one. Okay. Let's start with the simplest one. The development interface, for example, is very different for both of them. One, like what Anna said, it's a jar file. It's an embeddable jar in your Java code. So you write your Java code just like you normally do, and you run that in your code, and it just does the stream processing in the background with the Java code itself. Flink and ksql, for example, are in a different realm altogether, where they run as clusters. You run jobs there, they do the job, they event out the result set or whatever it is, right? The whole premise is that, for me personally, this is one of the biggest differences from a development perspective, that one is your regular native development interface, as long as you work with Java, of course. For others, they are like frameworks which are deployed somewhere else, clustered compute, for lack of a better term, right? They do that. Architecturally, I think they are a lot different as well. Like, for example, the state management. For example, K-streams, KSQL, both rely on Kafka for their actual persistent stores, right? Now, both of them use RocksDB underneath as well for local storage. But again, the actual storage is in Kafka. So if something goes wrong, something goes kaput in that deployed code, when a new instance comes up, it feeds back data from that Kafka topic, rehydrates itself, and starts working again. Simple play. There is no additional components. All you need is Kafka and you're good to go, right? Basically, that's it. With something like Flink, it has its own internal storage. So it does its own checkpointing, watermarking, storage, snapshot retention. All that stuff is done in Flink. It works with Kafka because it has connectors to Kafka, the source, sync, both. But it's its own framework and its own deployable where it works. So a little bit of a difference. It's a major one, but again, from an operational perspective, that becomes a bigger thing to understand, right? That you need extra storage on the Flink side. You need additional compute nodes, all that stuff for ksql and Flink. Whereas for K-streams, you're just running it as a Java job. That's it. That's all.
Yeah, it's always in the detail. So let's spend a little bit more time on Flink. Do you think our squirrel friend makes stream processing any more accessible to users?
Yeah, I personally believe, I think so. This is where I love having Flink as one of those contrasting frameworks where it combines streaming, it combines to an extent batch processing as well into the whole ecosystem. And another thing which it does is it has the huge part about Flink, which drives me towards it, is Java, and we have been talking about this, right? K-streams, Java only. KSQL has been SQL only, SQL-like only.
Right.
Whereas Flink, on the other hand, is Java API. It has a Python API. It has a SQL interface. So it has multiple places where you can say, hey, okay, my biz devs can just use SQL, so they can go into that particular realm. The actual developers who love working in Java, Python, they can just go to that other side of it where they can work through the APIs, native APIs, and get the same job done in a different fashion, which is much more controlled on their end. But again, this is majorly for me. I feel where Flink is a little more approachable because it blends both of those approaches together and says, hey, okay, if you need this, you still can use this. If you need this, you can still use this. And that's where I think it's the most powerful at this point.
Well, squirrels are usually pretty flexible, so it makes sense. It was a very appropriately picked mascot. And to kind of, just to add, I agree. I mean, there's something very powerful to say, hey, your back-end engineers, your data scientists, even DBAs, all of them can interact with it how they want, right? Do they want to use SQL queries for the DBAs? Do they want to write things in Python, maybe for the data scientists, and you still want to work with, the table API in Java? You could do that. It's very powerful to have one thing that makes data accessible to all those different personas.
Mm-hmm.
So are there any specific use cases where someone should consider K-streams over Flink or vice versa?
One of the big ones that come to my mind is, and this is a little bit more involved here, right? And I think I was talking to Anna about this a while ago as well. The event time is something very different. The way how time works for Flink and K-streams is very different. So those can kind of change the way how you look at use cases.
Interesting.
Right? For example, the way how Flink can actually do its aggregation, the windowing and all that stuff is by wall clock time, right? It does use wall clock time to close all those windows, aggregations and stuff like that. Whereas for Kafka Streams, by default, it uses the event time for doing all that stuff. So it needs an event to close a specific window. It does not close that. Right. So there are use cases which are driven towards that. There are use cases driven towards the wall clock time. So pick your choice according to what your needs are. And this is very specific. Not everybody, when they start using it, they realize that. But once you quickly start using it and getting into the deep end, you'll start realizing, oh, this is a little different. I'll have to maybe tweak my use case a little bit to work around that stuff.
Right. So when you really get into like the critical requirements for your use case, you start to look at, those slight differences and figure out which one is the right one for my use case.
Yeah. And the other big one, right? And so this is where another thing for Kafka Streams, it was designed as a pretty lightweight Java library. That's it, right? It was supposed to work with your Java code to get you into data streaming pretty easily, make it work with Kafka as easy as possible, and get your job done, right? Whereas Flink had a compute-intensive infrastructure in mind. It was built for compute. Small, large, extra large, doesn't matter, right? The whole point was that, hey, I'll give you a compute instance where you can do whatever you like. If you give me data, I'll give you the compute and get the output as necessary. So there is a little bit of a difference in the way how they are optimized as well for use cases.
So this next question is for both of you. And we'll start with you, Abhishek. Can you share a specific tactic that has significantly improved the customer stream processing journey?
The easiest one to pick here is POC as early as possible. Once you do the POC, right, you'll realize what the immediate points of issues, contention points might be for me and how to resolve them, move forward. And once you get into the actual implementation stage or the design stage, you will basically start with much faster speed, right? You'll just, hey, okay, check. We've already done this. This is already done. We can move forward. The other big one is for me, and I love telling it to my customers as observability. You started from the get-go, you'll be set for life.
Yes.
If you don't, you will be in a painful state when you will realize it, and then the implementation is going to be much harder as well at that point of time.
It's surprising how many people build things out without having metrics in mind. It's really
exactly. So
yeah.
I'll give it to you, Anna.
I would say you're 100% right. The first question that you start playing, first question you ask as soon as you event is you play the game of where's my message. You're like 10 microserve, where's my message? Oh no. So being able to know that and get that answer quickly is very important. I would say the one thing that I've seen is I always say, allow yourself to automate and accept and accommodate your manual processes naturally. And what I mean by that is have an error router, have a queue, right? And people always say things like, well, you're never going to be able to enumerate every single possible. Some things you may not be able to automatically solve now. Some things you don't know what you don't know. But if you build an error routing service or a service that can flag these things up, then as you build these profiles, you go, oh, well, this is easy. I just have to resubmit this. Or this is easy. I can do X. You can grab that event and then build a process to automate it. The ones that you can't, pick them up, open a ticket. I've seen, that is still an acceptable thing to do these days. At least you know. At least you don't have to go figure it out, then open a ticket, right? At least you've got an error message with context. Like, it's a beautiful thing, right? And so that's the thing I think, to me, I've seen people do early and be very successful with, because they're able to show this continuous improvement to the old process. Well, think about this. Before this, we had to open a ticket and it took 24 hours. Anything you can resolve now automatically based on that event you threw, right? Business value. So while at the same time, anything you can't, you still have a way to do it. So that's kind of like I was looking for one that I've seen that is not as obvious as some of the other ones I could name. And that is one I think, error routing service, embrace it, love it, have a schema, make sure everybody has to use it.
Yeah, it's really powerful because especially if you're automating, and like if a group or an organization was manually dealing with all of those errors, now you automate some percentage of it. Now you've opened up more bandwidth to kind of remediate the other issues. So you can slowly over time shift it almost everything to automatic, and then you have this manpower there that can handle the one-offs. So yeah, that's a really good one. I didn't think about that.
As an extension of that, I would just want to add, maybe start with the fully managed services first when you're just exploring things.
Sure.
That basically cuts down on your deployment times, your figuring out times, your OpEx to get the systems out, installing them, figuring out the networking, and making sure everything is tuned, optimized, and working for those sets. Most of the fully managed systems have already kind of done that for their customers, right? You can, even if you want to start there. If it's a use case fit enough for cloud, start with the fully managed service. That's probably going to save a lot of cycles for you.
That's true. I mean, it really goes back to what you said, like start with a POC. What's the fastest way to do that with a fully managed service? Because as you mentioned, Flink itself has its own processing, its own compute nodes, and kind of stringing all that together open source is really non-trivial, especially if the whole idea is to make sure that this is going to work for us in the first place.
Exactly.
So continuing with you, Abhishek, what are the top 3 tools a data streaming engineer should have in their stream processing toolbox? Or are there any tools they should avoid, like batch workloads?
I'm a little biased here, so I'm going to start with tools first. Kafka, Flink, Kubernetes to a certain extent, and then observability. Like I've been a really big proponent of observability. Any observability tools, you'll want that. Kafka for its scale, right? You will hit the ground running with as much data as you want. You won't have to care about it. Flink for its massive compute, so that you can do all the compute on the data that you're getting from the volume, the veracity, velocity, all that stuff won't matter. Kubernetes so that you can scale all those compute out if you need to. Easy, quick way, right? Observability, we know we need to see all that stuff, where the data is flowing, how that's flowing, error, all those error messages, all those things to observe, making sure that everything has been done properly. Observability. And additionally, just as a brownie point for Confluent, I think the VS Code extension, that will probably be something which I'll tell any new developer to say, hey, okay, you're getting into Confluent? Okay, use this VS Code extension. This will help you streamline your workflow much faster than how you would do it in like 5-item windows.
Yeah, so much excitement around that piece. That extension's awesome. So Anna, how about you? Any tools you could call out?
Yeah, I love this because that's the reason why Abhishek spends a lot of time with digital natives, right? My answer is going to be you should find something that runs in the zip, you know what I mean? It's because
Very different answer.
I spend a lot of time with people that are, I mean, they're still using Eclipse. You know what I mean? Like it's right. No, but I mean, I think, to Abhishek's point, if everybody could do that, and most people can at this day and age, I'm, kind of being a little, I think data streaming engineer is an interesting term.
Yeah.
What's a data streaming engineer? Is that what is that? Like, what's our definition of that? You can tell I was raised by a lawyer. Can't answer a question without asking a question. Are we thinking of like a data streaming engineer as somebody who's writing day one use cases like that are running the business? Or are we thinking of them as more of somebody who's writing, analytical programs on the back end, or things that are like 24-hour days? Or is it all of the above?
They're all the above. Anyone that's working without pauses, based on your definition, I think is a data streaming engineer.
Yeah, then, I would say make sure that you have access to the list of best talks on the Apache Kafka website.
That's a good idea.
Don't ever undervalue, that's one of the first things I tell people to do is go watch the list of the best talks.
Yeah.
There are great talks from customers, from people using Kafka in the real world. There are great talks from, Apache Kafka engineers about internals, if you want, right? Anything that's your slice. So I always, think you should have knowledge as a tool. And there are different ways, different people learn in different ways, right? If you don't want to watch a video, because sometimes that's annoying. And sometimes how people speed them up. Sometimes I slow them down to see how drunk people sound. Tim Bergeland and I, we sound trashed.
At 0.5? Yeah. Okay.
Yes. It's so embarrassing. We're like, it's great. But I think, if that's your way of learning, that's a great, resource. If not, there are so many good Kafka books out there, about, Kafka Essentials. Then there's K-Streams, Bill Bijak has his book.
Yeah.
I think it's Mitch Seymour has another one. If reading is, that's the way you absorb knowledge. And then, to Abhishek's point, if doing is the way you absorb knowledge, grab, whatever, IDE you happen to be in. Right. VS Code, you got an edge because the new one is really, really good.
Yeah.
But that's easy. Like I just remember bashing my head against the wall going, I remember looking at the K-Streams example repo and going, who wrote this? Like somebody whose PhD is in, and then I was like, oh no, it is Matthias. So yes,
That's
that is
why,
who.
the
Yeah. And
doctor
he was
wrote
like,
it. That's
he was
why,
like, I thought this was easy. I was like, yeah, I'm sure you did. I'm sure you did. You wrote a dissertation on. So that's the thing, now the examples that are out there, I think are much easier, right? Like, it's frustrating, even something as simple as printing an example that doesn't have a schema attached to it, that's Avro that needs you to stand up schema registry.
Yeah.
What the hey? So that's why, I always put all of my demos in my GitHub repo. They just use JSON that's hard coded in a JUnit test, so you can change it to be your JSON.
That's right. You don't even need to figure out what a schema is.
Correct.
Right.
So I would say that too is, find good examples, play around with them. To Abhishek's point, get. So that's what I would say. Curiosity is the ultimate tool.
Oh, I love that. I like this idea of going back to these talks that are, they might be a couple years old, but they're still relevant, right?
So
There's
relevant.
a reason why they're popular.
Yes.
And they really help you, kind of build up that foundation of the right way to do things. And I can't help but laugh and think that there's the segment of people out there that learn by listening to people that are drunk, to speeches.
Yeah.
So
Drunk
they
history.
exclusively watch things on. Well, yes, exactly. That's how I learn. I learn through drunk histories.
That's right.
That's great. So, Abhishek, in your experience, how do customers evaluate and select new tools for their data stack? And how do they balance factors like scalability, cost, and integration with their existing systems?
So I'm going to speak again from a digital native perspective, like what Anna mentioned earlier, right? And most of my customers are pretty much cutting edge. For them, the biggest thing is, can any of your other tools handle the volume, velocity, and veracity? If they can handle the 3 Vs, we can put it into the evaluation bucket. If they can't, I don't think it's going to work out, because right now the volume, first of all, is huge. The velocity is even worse because of the entire internet age that everything spawns events at this point of time. Anything and everything you do spawns events. The accuracy has to be really good, because then that's only when sidetrack, but again, ad revenues, for example, right? They come from when you do stuff. And if you are missing those, the accuracy goes down, you lose revenue. That's one of the big things. And so all those things do have a prominent effect on at least my digital native side of customers. Other big points are actually if they can integrate really well with the legacy systems or not. Some of my customers still, a lot of my customers actually still have legacy integrations that they need to build up and say, okay, I'm not able to integrate with this customer. So that's where some things like the Kafka Connect framework comes in. The integration ETL workflows, there are numerous of them available which can talk to Kafka, talk to the other side and put the data into Kafka as well. Those come in handy. But if they don't have that, how do they integrate with newer systems? That's one of the big things as well. And another one nowadays, and I've started seeing this pattern recently, is the reliability. Is my data going to be available if there is an issue? And if not, what is my disaster recovery for that? Right? I need my system to be running all the time, even if your system, one side of the system is not working. So those are the few things that I've seen the customers ask for.
Yeah. That's great. So you touched on something I hadn't thought of, especially with digital native. You know, a lot of non-digital native customers are thinking about what can I integrate with existing systems, where digital native may be thinking about where am I going to send my data 2, 3 years, 4 years from now, like future-proofing the data destination. So that's an interesting factor. Anna, how about you? What about your customers from the non-digital native side of things? How do they evaluate and select tools? Similar way?
No, probably not. So some of it, there's overlap, right? I mean, like, yeah, obviously, like it has to work, but I think really there's a lot of like time to value. What's the time to value, and then what's future proofing, and also like I was just gonna say, welcome to my, because I spend a ton of time BCPDR. How do we do high availability? How do we stretch clusters? How do we do all of these things? Because it isn't that, boy, it's bad if it fails. It's that it can't fail. It absolutely cannot fail. Because if it does, people can't get money out of the ATM. People can't cash checks. If flights don't take, like, there's all of this big things that happen, if these things don't, those critical use cases, right? And some of those are digital native too, right? Like, my mom wants to get her groceries, man. Like there are things in that day and age too, but the regulatory component in the industries that I work with, a lot of them is much, much, much higher. Yeah. And so there's a lot of that type of intricacy. Can we provide that level of security? Is it flexible enough? And also, again, right, like, can it talk to the mainframe? Because they're everywhere. Which it can, yay. So I would say like that is a big component. And the other component that I would say is how much expertise and how many known, good, successful patterns for my vertical exist. Whether it's insurance, whether it's, banking, whether it's healthcare. There are people, and they know who they are, that are the leading people of these industries, right? And everybody else, for the most part, goes, did that work? What are they doing? Right? That literally, right? Exactly. And then they're like, hey. So that's really something, because it's low risk, right? You're trying to balance risk versus reward, and it's very risky to go first. So understanding and having these best practices in these industries, which we absolutely have. I mean, more so than I think any other technology, when it comes to data motion, we have these beautiful patterns to handle pretty much everything.
Yeah.
In these, kind of stalwart, what I like to call them the money-making verticals. Some people call them by a different name. That's what I call them because I love the banks. Yes. But that really helps. And I think it's really important because customers, they want assurance that this is going to work, that we know all the edge cases. We know how to guide them. We know how to, and I'm very proud of the hours and toil that we save customers. That is always, makes me feel really, really good, is like, hey, right? I told them, they would never have done that because I was there. Ha ha. And now everything just works. And it's like, it's this whole thing. I have zero patience for making the same mistakes twice. I always say this to everybody in this household. Everybody makes mistakes. You make a mistake, we don't got a problem. You make it twice, then we're going to have a conversation. So I view kind of part of the heart of our job is to live that mantra. And, no customer makes the same mistake twice because we know. And I think that is hugely valuable. And I think companies do look for that. They look for people who are able to advise on that level, which I think is very valuable.
That's fantastic. Yeah. Who can help me pioneer? Who can help me, only make a mistake one time? That's a pretty powerful piece. And the fact that we closed on banks is a very good segue into our next segment. So we've heard your winning strategies and tactics, but now we're going to watch a quick clip from a real world user of stream processing. And I'd love to get both of your reactions.
I lead a team that manages the operations, infrastructure, and engineering at Citizens. And my job is to make data available to my business partners and empower them to delivering incredible customer experiences. The expectations of the customers are through the roof right now. And the need to make data available in real time or near real time has never been greater, whether it is for fraud prevention, whether it's for risk management, whether it's for hyper-personalization, whether it's our digital channels and self-service channels. Making data available in real time is very, very important. And really the two pillars of doing that is APIs and streaming. We have been, over the past 3 years, in a journey to modernize our technology, infrastructure, and applications. We have a lot of legacy platforms on the mainframe, for example, and it's really, really important to unleash the data from these. We're doing that using change data capture, using Confluent. So I think we are one of the early adopters of Confluent Power Platform, and it's been really a key and important tool for us in unleashing data from the mainframe. When we came to the point where we had to stand up an enterprise-grade streaming data platform, we looked at multiple options, and Confluent was a clear winner, and it fit right into our overall ecosystem. The data footprint at any organization has increased exponentially. So how do you get data from point A to point B, and who are the consumers that need to receive that data at what time? How do you ensure the data is secure? How do you ensure it's accurate? So this is a very, very complex problem to solve. I think Confluent and what they do with streaming data, make it really easy for us to exchange data between applications. This in turn enables the business to come up with actionable insights in real time or near real time. And the demand for this has never been greater. What is the future of streaming data at Citizens? I think it's going to explode. So where would we be without data streaming platform? I think we will be out of business. Customers expect real-time experiences, and if we don't deliver it to them, they're going to go somewhere else. For us to be in business, stream data processing and real-time analytics on data in motion and actionable insights is going to be really very, very foundational to our existence.
So we just heard from Citizens Bank about how they're using stream processing and data streaming for multiple use cases, hyper-personalization, risk management. We heard mainframe, we heard CDC. Do you think this is a common scenario, everything we heard from Citizens across all banks that we work with?
So I think, I think the thing you can tell, right, is, so I always talk about my Ma's credit union. It's like open Tuesday for like 2 hours. And like, good luck finding a parking spot. And now you see credit unions participating in FedNow. You see credit unions going to real time, and credit unions have a very loyal customer base, very, very loyal. They're kind of like the leading and lagging indicator, right? And so if you look at, credit unions, they're coming to the party now. People expect these things. You don't expect to, when was the last time you cashed a check? I'm just interested. Honestly asking.
Yeah, I do it through like a mobile app. So I take a picture of it.
But that doesn't count. When was the last time you put it in one of those pneumatic tubes?
Oh my God, a decade ago?
Right. I actually missed those pneumatic tubes because they were super fun, but not at the expense of taking a picture on my phone and it telling me to move to a darker background.
Yeah, I like that.
Right. So that's the thing is absolutely the expectations of consumers keep jumping ahead and ahead and ahead. And it's like what I talked about, it's getting that time back. But please, yet again, use it for something peaceful and that fills you as a person, not to shove more stress.
Yeah, there's got to be a more fun way to use those tubes. Like, I feel like people should deliver food through those tubes.
Oh my God, they're amazing. I love pneumatic tubes.
There'd be a sandwich in there. Like, that would be the greatest.
Totally having one on my island.
Abhishek, was there anything else in that video that kind of popped out to you that you wanted to comment on?
At this point, I kind of, honestly, I just agree to you guys. Whatever you said, this is right on point, because the solutions have changed because the technology is moving fast. The expectations from the customers are moving faster than those. So earlier, like back in India, right? When I was in India, it was like, hey, we go to the bank, we get a passbook signed which will detail out all the transactions. They'll print it out on your passbook and say, hey, okay, these are the current transactions and this is the current balance. People don't care anymore. They don't want to go to the banks for all that stuff anymore. They just want, okay, what's my current balance and what can I do with it? Can I transfer it real time without having to sign checks and handing over a hard copy to somebody else? That's what people need. And that's what is evolving everybody, not just the banks, to get to more real time, rather than saying, hey, okay, it's going to take like 5 days to get your cash in any way.
Yeah, I like that take. I mean, to generalize it, if you can take tasks that people need to do and you can make it easier, better, faster, you're on to something. Right? And banking is a great example of that. So we discussed what stream processing is, strategies, what a data streaming engineer is, and we've heard from one of our customers on how data streaming is transforming their organization. Now it's time for real hard-hitting stuff, our data streaming meme of the week.
I'm going.
Oh, this is on the nose, bang on point.
So I really like this meme. It really kind of talks to how difficult it is to set up stream processing, in this case, Flink, alongside data streaming and all the work it takes when you start thinking about the various angles, observability, scale, et cetera, et cetera. What are your thoughts on this particular meme, and does it resonate with you?
Is that Mr. Beast?
That's Mr. Beats. I think it's KSI and one of the
what?
Paul
Look at
brothers.
I got kids. That's my first thought. I know that man.
You know that, man. Yeah.
Mm-hmm.
No, so by all means, like whatever your reactions are, like
proud
I
of
think,
me.
yeah, I mean it's a great meme. So go ahead, Abhishek, if you want to. What are your thoughts?
At this point of time, this is something which everybody runs into once they start deploying open source Kafka, this is where it starts getting harder, where, hey, I need more topics, I need more partitions, I need more disaster recovery, I need better reliability, I need things to just work. Why can't we just make them work? And this is where it gets to, right? You start small, everything just works. As it gets bigger, the harder it gets to manage. The tunables, the things to worry about, the list of laundry list actually gets longer. I love this post. First of all, the meme is awesome.
Yeah.
That kind of sells the whole point of why you kind of should talk to a fully managed system before you start standing up your own system by yourself.
Right, until it falls over on top of you, and now you're crushed under your open source.
Exactly.
Any thoughts, Anna?
Yeah, I mean, I would say like one of the first questions I always ask people, like when they're like, we're great at managing Kafka, is what version of Kafka are you running? And then like,
great question.
Well, either two things happen. Either like, they're doing a good job and they're not embarrassed, or they're like, I'm like, what's that? I'm sorry. Can you louder? Right. I mean, because the thing is, and that's another question. It's like, then you start to ask, you just tease that out. You're like, hey, do you not upgrade? Because every time you upgrade, the clients fail. They're like, no.
Maybe.
And you're like, well, maybe. Right. So you kind of tease it out. And that's when I think you're at a precipice. It's like when you have a really hard time even doing the simple thing.
Yeah. Right.
Multi-tenancy is super hard in AK. In terms of like you're rate limiting your controls, your ability to box out, even though like requests, like, I love request quotas. They're a bit esoteric to understand. But it's not that AK doesn't have things. It's just that there's so much DIY in that to run a truly multi-tenant stack yourself. Like if you can't, like, that's our job, right? It would be, and I think, Dr. Anna Posser, who is amazing and incredible, like you can't get better than her. So you should use us because we have her. That would be my sales pitch. She's a genius. What do you want?
I love it. Yeah, and I think a lot of people start with these systems and they don't think about them as multi-tenant, but especially in an organization like a bank, like eventually you're going to want to have other teams on board, and you don't necessarily want to replicate that. Do you really need to rebuild everything, or have multiple Flink clusters on top of multiple Kafka clusters? That would be a big challenge. So don't do that. Look at something fully managed. Now, let's get to our next segment. So before I let you both go, we're going to do a lightning round. Bite-sized questions, that's B-Y-T-E. Bite-sized answers, like hot takes, but schema-backed and serialized. Are you ready?
I'm ready.
All right, we're going to go back and forth.
Go
Anna,
Bills.
What is something you hate about IT?
The clown.
The what? The clown?
Yeah, and I don't like that clown.
Pennywise is just catching strays today. Abhishek, what's the last piece of media you streamed?
Squid Games 2.
Nice. I still got to catch up on one. Anna, what's a hobby that you enjoy that helps you think differently about working with data across a large enterprise?
Lockpicking.
Lockpicking. Do you watch The Lockpicking Lawyer?
Yeah, I've seen him before. His stuff is pretty good. It absolutely is. A long time
It is.
lockpicker over here.
Nice. Okay. Now, how does that help you work with data across a large enterprise?
Well, you have to unlock things one at a time. You have to be sensitive, and everybody has to work together or you're screwed.
I like it. And you don't always have the key, right?
No, you never have the key
You
in
never have-
lockpicking.
I love it. Abhishek, can you name a book or resource that has influenced your approach to building event-driven architecture or implementing data streaming?
I would go with the designing event-based systems.
Yes.
That is a great book. I love that. It influenced me a lot when I was starting with Confluent, so it was amazing.
That's great. It's still a very popular asset
Yeah.
for us, so I couldn't agree more. Anna, what's your advice for a first-time chief data officer or someone with the equivalent impressive title like that?
I would say embrace evolution, don't tolerate it. And what I mean by that is embrace changes in your data schemas, embrace changes in your data sources, embrace changes in regulation of your data. Make sure your design embraces evolution. It doesn't just tolerate it. Otherwise, your life is going to be messy, and we see that all over. And I think that's rare today. People tolerate evolution. They don't embrace it yet.
I like that. Very good. Embrace change. Any final thoughts or anything to plug for either of you?
Go Bills. Let's do this. That's my final thought. Let's go
I like that.
Buffalo.
Let's go Buffalo. How about you, Abhishek?
I think this was a great experience for me. So I'm learning so many new things now. Go Buff.
Okay.
Yeah, that's right.
Yeah.
That's great. Yeah, jump on the train. Excellent. Well, thank you both so much for joining me today, Anna and Abhishek. And for the audience, please do stick around after this. I'll be giving you my 3 top takeaways in 2 minutes. Man, that was a great conversation with Anna and Abhishek. Here are my top 3 takeaways. First, I love what Anna said. There is no pause in data streaming, right? That's a whole different way of thinking about event-driven architectures. Now you have to start building things. You have to start writing code that does not account for pauses, because those events are going to continuously come in and they need to be continuously actioned. So how do I know it's an event-driven architecture? Well, there's no pauses in the requirements. That's a great one. Stream processing, or the idea of stream processing, making life's tasks more efficient, right? So this idea that now I don't need to go and deposit a check, or I don't need to necessarily go to the dentist to check out to see if I have a cavity. I just need to take a picture of my teeth. Incredible. And when stream processing makes life a little bit easier, make sure that you take that time back for yourself. Don't just throw it back into more work. I mean, work is important and it's all necessary, but take a little time for yourself. And the last point that I really want to call out is that Flink is for everyone, right? It's super accessible, whether you're a DBA who loves SQL, or you're a backend engineer who wants to write everything in Java, or you're a data scientist who wants to query things through Python. Flink has modules and APIs that are for everyone, that make it accessible to anyone that wants to work with data in real time. Really impressive. That's it for this episode of Life is But a Stream. Thanks again to Anna and Abhishek for joining us, and thanks to you for tuning in. As always, we're brought to you by Confluent. The Confluent data streaming platform is the data advantage every organization needs to innovate today and win tomorrow. Your unified solution to stream, connect, process, and govern your data starts at confluent.io. If you'd like to connect, find me on LinkedIn, tell a friend or coworker about us, and subscribe to the show so that you never miss an episode. We'll see you next time.